So any idea what's going to be the subject of today's lecture?
Itemization.
Itemizations. Is it just itemizations or something to do with? Yeah, structures and itemization. So today's lecture is on itemization plus structures. So why do we say plus? What's it to do with combining structures and itemization? Okay, I will get started and I will expect you're going to help me. So first, so much we have done so far was about starting with built-in data types, trying to organize our data, and based on the organization, we are looking how do we organize our own function designs. So we have seen how to use built-in data types like numbers, strings, and so on. Then we decided to look at, well, sometimes we do use some part of it. So we do have a subset of the whole set. Then we represent it in our function, and we implement them. And last week we have seen how we can come up with our own data structures and what kind of functionalities are necessary when we work on our data structures. And today we are going to combine itemization and usage of our structures within the subset of the universe of data we had. So that means sometimes you might need to design your own data types and design a function which can expect not a single data type you have designed or the ones that are already existing, but a subset of them. So how would you combine these two things together to design a function? But we are going to start with a simple function which consumes one of the data we have designed and see how we can extend this to accommodate this new perspective. So our purpose is how are we going to reflect again and again, as usual, the organization of data to organization of the function. Okay, this is important to make sure and make clear because starting next week on, we are going to look into recursive functions, and we are not going to jump into how we can come up with a function design where it's recursive, but we will start again from data. What kind of data we need to organize to make it where we need to apply a recursive function. And the design principles are the same. So what you do when you design anything with even itemization and structures is the same. So if you apply the same design approach without having any idea any recursive functions in advance, you should be able to come up a recursive function definition mechanically. So that's why in this lecture we are going to wrap up things, and starting next week on we will further move on to self-referential data structures like lists. Using those self-referential data structures, how we can design recursive functions. So that's why it's important to make clear what's the design principles of reflecting your data organization to your function organization. Okay, now let's start with a simple example. Let's assume that we want to design a function which draws some geometric shape. Let's say which draws a triangle. Okay, so we want to design a function which draws a triangle. So let's make things simpler in order to demonstrate the design approach. Let's say we want to use one of our built-in libraries like ImageSS. It has a built-in function which can draw a triangle directly. You could use there are different ways to design it, but let's first of all check how can we use this built-in data, this built-in function, which may help us to draw a triangle. Do you remember if you have done before? So if it's something called triangle, of course you can always go help desk and look at the details, but it expects 3 inputs. So this is a function application. So it's an equidistance triangle, eşkenar üçgen. So we want to have we need to have this length of the triangle, and it's going to, since it's going to be drawing, we want to know if it's like outline or a solid filled-in triangle. So let's say we want to draw an outlined triangle, and the color. Let's say you want to have an orange triangle. Okay. So that means I need to complete all inputs. Why is it so? Because we need to activate the teach pack in first place. Wrong? Yep. That was wrong. Yeah. Now we have we do have a simple triangle down here. I guess it's apparent. So now this is the thing. If you were able to use this one in your using interactive window, but if you might want to say, well, for this triangle, I'm going to keep, let's say, the outline constant, the shade, whether it's filled in or not, constant. But I just don't want to play these two variables, the length and the color. So I want to design my own function, which draws triangles based on these two different parameters. Okay. So that's but this is the thing. But now we have a constraint. Let's say you are using this, for instance, in a simulation environment in Big Bang, where you can only have a single data, a single item. So how would you come up with a function contract, or before that, how would you come up with new data, where you keep only these two pieces of the information, like only the color and the length? How would you organize your data? But so again, let me ask you: if you want to design a function which takes length and the color and draws a triangle, what will be the straightforward contract of your function? What would the signature of your function in this case? You want to take the length and the color and draw the image. Number, string, and output will image. But in this function, you have two inputs. Now, our purpose is to be able to have a single input for the function. How would you come up with a solution in this case? A structure. So that's the thing. So we want to go and say, well, in this case, I need to pack the items I need into a structure. So this is what we are doing now. It's like repeating or reviewing last week's lecture. So the thing is, then you would come with a new data type. But in this case, you would just keep the pieces of the information, not all three ones, because you decide, well, I'm going to play only with two variables, and this will be constant. So why do I have to carry on all the same information, constant information all the time? And if there is also another constraint that you can only use one single input. So that means you will have the name of the function and also the like selectors, the components of your function. So we have a length information, and we would have we will have a color information. So let's keep just the. So whatever information you give, it's fine. The name you pick is okay, but we know that it's length and color. So it's always good to give full names as a style, length, and color. So it's always good to say triangle, let's say info or data. So this is, I mean, anything it fits. So having this would enable, once you run the program, enable the environment, in this particular environment, which is Dr. Record, to generate a set of functions. What set of functions does it generate? So can you tell me what set of functions does it generate? If you say, now let's have this one. Now somehow the environment compiled, and it went and came up with the so what we have done is the organization of data, our own data. So when you organize your own data structures, what set of functionalities you need to have to go further? Yunus? I mean, this is the data organization. It's not complete, but once you have organized your data structures, what functionalities you need to have to be able to work on this data? So in this case, make try data, which means you need to have a routine which initiates, actually which makes an instance of data. So that's why you would have a make, for instance, a make dash try data function. And what else?
A selector to call data.
Yeah, selectors to be able to extract data. In this case, how many selectors we need to have? Two selectors. And in this environment, once it's compiled, the neighborhood selectors will be length, try data, color. That will be neighborhood selectors. What else is generated and is necessary when you design your own data structures? So now we are able to store data by using make. So this is one functionality, how we can instantiate, allocate space for your data. Second was, how can you retrieve data, and what else?
Predicators.
A predicate to be able to check if the given input, any given input, is one of those you have designed. Is it, for instance, a try data or not? So you need to make sure that whenever you organize your data, there are always those things that you need to remember that there are functionalities you need to have. Okay? So, but in order to complete our data definition, we should explain more, because if someone looks at that, yeah, certainly the names imply something. It implies the interpretation, what they represent, but it doesn't tell what kind of data type the length field contains, or what kind of color data type, what kind of data type you have used to represent the color. So how would you continue to complete it? So you will say, it's like, or make, for instance, it's a make try struct, try data, and it was going to be, for instance, number and the string. So that means, or you can explain that length is a number which stands for the length of the triangle. Color is a string, stands for the color of the triangle. So that will be straightforward things. So now let's say we have an example of this data, an instance of this data, like an example try, and you would say make try data. So now we are initiating, let's make it larger maybe, and red. Okay. So now the question is, if you were up to, and this is what we're going to do indeed, design a function which consumes a try data. So that means this part of the signature will say that any f for try data, this is like, we're going to design a function for try data. It's going to consume, yes, try data. At the moment, we don't care what is going to be the output. But what I want to make sure that how would you organize your template? So now we can keep going. Maybe for the header of the function, let's make it just an f, like any generic f, and this is input name of the input. Let's say this is a simple header, but it doesn't fit to the name of the things we have done here, so it's better to keep the same name to be consistent. So, what is the template for this function?
What is that for? What is it doing?
So, at the moment, it's a generic function. So it means we know that it consumes this type of this data, but we don't know what it's going to produce. So that's why it's just a generic function name. So
We will call the structure from selectors for.
yeah. So what Kemal says that we will put the selectors inside. Why do you think so? Or what do you think? What was the guiding question for Kemal that he decided that he need to have selectors for this, have the selectors for this template? Millie? Okay. And other than Kemal? Can we? I mean, Kemal tells that we need to have selectors placed here in the body of the function for the template, to complete the template. And I'm asking, what might be the guiding question for Kemal, but he decides that we need to have selectors here. So because this is the question which is constant, whatever the data type you have when you deal with the function implement. Yunus? Yeah, I mean now you are giving the detail of the code which deals with how to get the selectors out. Okay? I mean you gave it to him, but I want you to be clear. What was the motivation on templates? Yes, Mujahid?
We should have correct inputs, and we know that we will be using three datas, these objects, these structs, color and length attributes. So we have to call selector functions.
So so what do you say? How am I going to access the data? This is the general question the general motivation. Was it that you wanted to say? Yeah. Yes. So this is the thing. It doesn't matter what input is, but it doesn't matter how we organize the data. But the motivation is always the same. I'm repeating this. I'm asking this question over and over again, because of course this is not the whole design. This is a very important component process in the design, but it's important to know what is the motivation in a template rather than just write a template. So in this case we would go and say, well, I mean, if I was designing the code, I mean, even without knowing that, I should think of more clearly and exclusively about the template, I would say, well, I will start with whatever I have. What I have is just the input, T. So now I will say, how can I use this input? So this is the template stage. And you look at it, T is a try data. So what the try data is, and you go back and check you see try data is your own data structure, and it has organized in a way that it has two components, one length and one color. So that means, well, I can't use the package as given, but I need to open it up. So that's why you would use you would write down and make your attributes in this case ready to go. So that means you will say, well, this thing has these functions generated automatically, which enables me to extract the length information, and again the same thing, it will enable me to be able to access to color information. So that's how you would generate the color and the length of the thing. So now still you need to make sure that what do you have here. Well, if we look at this one, now what kind of data you have here? Yeah, it's what it represents, but what kind of data that will be? Yeah, this is number. So that means here I have a number, which means that I can use this immediately. Then I won't think further about what to do about this one. How about this thing? It's a string, or maybe it's maybe not any string, but indeed it's a color. Let's say, I mean, we don't say like, because not everything, but those major, I don't know how many of them are there. So actually it's like itemization in a way. So this is how, but we know that color is indeed it's a string. It's not a built-in or any complex compound data. It's actually, so I can use strings immediately. There's functions where I can work on the strings. So now we are done with the template. As we have seen, we don't know what the function is going to do. But still, the motivation behind the organization of template should enable us to make our data ready to go. So now let's complete. So what was our purpose? It was to be able to draw a triangle. Okay. So now let's go do this, explicit and more precise function that we are going to use. So now we can come and design let's say draw triangle. This is the name of the function. Or you can write it later with header. So we have try data. And what are we going to generate in this case? We are going to generate an image. And now let's give a proper header for the function. This is drawing a triangle, and this is a t, and so on. So we know the purpose of this function: to draw and to render whatever rendered information given in this package. So can you give me some example, and we can use in our test suites? Check expect. Yep. An input, example input. Oh yeah, it will be make tree data. So we can use this one of the make tree data, like make tree data, like 30 orange. That will be a triangle. Or yeah, this is the function input. What kind of outputs I would expect? What will be the output of this function? Can you see this properly? Yeah.
Image.
So it's the image, but I want to check expect. I want to tell what I expect from this function from output of this function. What it should produce. How would you write the image? So if you had the image, we can place the image. Instead we can write the code which generates this image. We know that we are going to use triangle built-in function from the library, and the triangle expects a length. Length is packed in the first component, is 30. It expects like a shape, whether it's filled in or not. Let's say we decide to have an outline, or maybe solid one, and it expects a color. In this case, it's orange. So it's even enough just a single example for this function. So what is the template of this function? Yeah, as Gizem says, it's the one we already have. We don't need to do a template from scratch. We know that it's again the same data as the input. So that's kind of generalization, as we have said. Templates is one of the good way to generalize your code. So what you would have is just to representational purpose. Well, now we have a different function name. Draw t, and that will be whole thing we need to have. So now can you think of completing this function? So how would you finish up and combine? So now the information we have. So whenever you do a really good proper template within the whole design recipe, that means you already completed, up to that point, you have completed a great portion of the whole code. And the final stage, you would combine the things. And one thing which is necessary to look at, when you design a template, your focus is to make the data ready. But it's just, in this case, you go and check your header. From the header, you might need to go and check your data organization. So that means whenever you design within the process, you go back and forth of the stages. So you complete that part. So it's when it's time to complete the implementation, that means you need to combine whatever you have so far. So for this case, if I was taking notes to myself, I will say, well, when you design the implementation, the complete implementation at this stage, first, this is the act you will be repeating all the time. First, check what was the purpose of this function, because you might have forgotten while you were dealing with the template and so on. And check the examples and test cases. So that will refresh what was the purpose of the function, how would you now combine input data, which is ready, to produce the output. So that's why, in this case, it's really trivial. The purpose is so clear, and the examples are up there. And also, as you have realized, examples are also going to be used as part of the code. So now how would you combine, what will be the code to finish up? Triangle, that means I'm going to use this function. But instead of concrete cases, I'm going to use the triangle and the data I have made ready to go. So I will use a triangle function. It's going to be a combining thing. And triangle expects what? A length information. I do have length information here ready, made at the end of the template stage. So that means I don't need to do anything else to access to length information. What else? We decided to use, this is the constant thing, so I'm going to put it down there. So I will use a solid. And what else triangle expects? I need to give a color. Where is the color information? It's ready to go. So this is really a trivial example, but it doesn't matter what the complexity of your function is. The pattern, the act you need to do always the same. But the more complex data you have, you need to be more careful, but it's always the same activity we need to do. So now we have finished up your implementation. So let's check if there is any error. Yeah, this name was defined before. Probably it was defined by the header. So we will repeat it. A triangle expects solids, outline, or because do you know what's wrong here? Because it doesn't expect. So it should be small case. Let's check again. So there was one single pass and the test was passed. So now that was a kind of repeat for actual designing data structures, using our data structures and reflecting the usage of data structures in our own design. So this is like a review of last week's lecture. But now let's move on. Again, with using this very trivial example, maybe, but let's move on how we can extend, make a more general function. So that means whenever we move on, actually we do improve generalization and abstraction layers or abstraction processes. So now we want to design a function which can, the same function which can draw not only a single geometric shape like a triangle, but it expects maybe a set of geometric shapes as input and identifies them and draws, renders the shapes with the proper images. So let's say we want to design a function which can draw a triangle, a circle, and a square, or a rectangle. It's a subset of geometric shapes. So what would you do if so far we have designed a function in this one, the template is here, which can just draw a triangle. But we want to move further, and we should be able to update our function, which can accommodate different inputs, like different or data about different geometric shapes, and designs and actually produces images. So, what will be your first reaction to move on? Okay? Yeah. What would you do now? I mean, if you have now, what's your first reaction in this case? What will be your first reaction to go further?
I have a question.
Yeah.
Our function will use one argument or
A single argument. This is the case. Yeah, good question. Now we are allowed to use a single argument.
what different?
So, but it should be producing different geometric shapes with the same function. So, in a way, it's not that, but like polymorphic function. Not maybe exactly, but it's a very similar idea to polymorphic functions. So it should expect different sets of inputs, but it's going to be one single input of the function. But it should be able to produce different images. So it will be an upper hand on this function, which only can draw a triangle. So what would you do? I mean, how would you sit and start designing a function for this purpose? Where would you start? Okay, did you come up with any idea?
Finding a new structure.
New structure, yes, for what?
For geometric shapes.
Yeah, for different geometric shapes. First of all, that means you need to, because every geometric shape might be, for each geometric shape, you might need to have different pieces of data. Like we have done for the triangle, that means we need to come up a set of different structures.
One step more general.
Yeah, then,
Shape,
like,
length and color.
uh-huh.
It gives us a triangle, but this
Well, like for instance, for a rectangle, for instance.
one step more general.
Yeah, for the rectangle, in this case, you might have two pieces of number, one for each length, and maybe if you want to play with the color, then another color. So now, there are of course different ways you can organize your data, a data definition for which accommodates different pieces of geometric shapes, information on geometric shapes. But now let's make it simpler. As we have done for the triangle, we want to design a new set of structures, like define a new, we have an example for this one. So let's define a information, a store, a record where we can keep the information on a circle. So it's going to be a circle data. So how many, but again, we are going to use built-in circle function. Do you remember how it works? I mean, probably you worked with radius and it's like triangle, but it's functions. So we can use the same, even the same field names for these things, but this case it will be for the circle. So it again will be make circle data. It should be defined struct, so we will be able to generate all those functions, routines. Nice. So for this circle data, it's again a number and a string, or maybe not all strings, but the colors. What else? Yep. Thanks. And what else we might need to have? For the, let's say for a rectangle deformation, we will have a rectangle data. So we will have lengths, or maybe instead of one length, we want to say a width, a depth, and also a color. So in this case, we will have the representation of this will be.
It's again defined structure.
Why I'm keeping forgetting? I don't know. Yes. So we will have a make rect data structure, which will have number, another number, and a string, which is a subset actually of colors. So now we have defined, organized two new types, which will be the data we are going to use. So now let's move on for this function, which can consume any of three and produce image accordingly. But that means what we are doing is like that. There are lots of other geometric shapes. What we have trying to do is just pick a subset of them. So that means we need to make clear that what we expect in this for this function is not all geometric shapes, but just these three of them. Does it remind you anything, like about how we select pieces of data or universe of data? So that means now we have to somehow, because we are not complete with the data definition or our data analysis. We need to make sure that for the function I'm going to use, I'm expecting only these three different geometric shapes. So I'm not expecting all sets of known geometric shapes, just three items. So how would you combine and tell that this is the data you expect.
In our function.
Yes, Elif?
I just want to say we have to optimization.
Yeah, we can. Yeah, we need to do optimization, exactly. So that means we select a subset of geometric shapes, and there might be any different representation of geometric shapes, but we are going to expect only these 3 representations.
And previous.
Yeah, so that means we need to say, well, my own data is like you can come up with a name because it's going to be identifier for this geometric shape. You can say M shape. M stands for my shape. I don't know. M shape is one of. So you would say it's one of triangle. One is can be a rectangle, a triangle, or a circle, but not any different representation. But your own data representation. That means it can be a structure which can be instantiated by make try data, which means it should have a number and a string. So that can be one of the cases. Other than that one, you can have a circle data. So you will have a circle data. Again, it's a number for the radius, a string for the color. And you can have a rectangle data. Make rect data. It can be number for length, for width, a number for depth, and string for the color. So this is it looks like how we have defined our traffic light representations. We were using 3 strings, but this time for the shapes we expect, we have designed our own data. And we made it clear that we expect these things, and we call this data as M shape. So now let's design a function which produces images. It renders these kind of data and produces the images accordingly. So what will be the contract or signature of this function, such a function? Just the contract, the signature. So but what structure? No, we want to produce image. Yeah, we know that if you use image SS, if you produce using those things, it's going to produce an image data type. M shape, yes. I was expecting for this because not any structure, not anything else, but the thing we have organized. So it's going to produce an image. So this is going to be our header. Now this will be our header. Define. Draw. Let's say generate draw. We will expect a shape or shape for short, and we will produce something. So this is the header we are going to use over and over again. Probably. I mean, we are going to use. Now we have a function name, and our purpose is to draw one of those N shapes. So now let's give some examples. So let's have a check expect case which consumes circle data. Can you give me an example for this one? So that means you need to have make circle data, and it's like 25 or 9, I don't know why I came out with this one, and a color. Yep. Oh, yeah. If we do this, what would you expect as the output? Circle as the radius. Maybe let's make the circle shape outlined and red. So this is, for instance, the case where you input a circle data. So now let's have other cases. Test for the other cases. So how about if you have a triangle data? It's again, I'm just changing number. So that can be a triangle. But now you have to produce a triangle information. And for the triangle, you might decide to have a solid triangles. So that's it. How about a rectangle? So again, we need to, first of all, produce some input data for rectangle. So it's make rect data. So we prepare the data, let's say 20 to 30 and blue. So is it ready? Yeah. Now this is how we can write the function, how it will be applying the function. And the rectangle, I think that was the built-in function for the rectangle, is 20, 30, let's say keep it outline, and this should be blue. Are we okay with the test cases? Ah, it's not triangle, that's just a short version of it. Okay, I think hopefully this is the thing. So now we have completed the information between input and output. I mean, so far within the design. Now we want to design the template for this function. So this is actually the main subject, the whole point of this lecture, today's lecture. So we have, what was the name of the function? Draw. Actually, we do have a header. It's always good to use your header. So this is the name of the function. So how are we going to organize our template?
Conditions.
Yeah, we need conditions. Why do we need conditions?
Check which data.
Yeah, because we now, the whole purpose, as we have made it clear again, to be able to make our data ready to go. So, and it's actually based on stages. So mechanically, my reaction will be put an S here. That means I'm going to use this input. Then I need to, so this is how you would interrelate between different stages of your design. Then I need to check what part of the design recipe you need to check. If you want to make sure that you're not doing something wrong. I mean, now we have to, what would you do at the moment?
We are going to check as.
We are going to check S, which means I'm going to check the contract of this function to understand what S stands for, what kind of data type it stands for. It tells me that M shape is an M shape. Now, if you have forgotten, or if you are completing someone else's design, and you will check what M shape is. Oh, it says that M shape is one of those 3 different structures. So that means if I need to access the data, I need to, separate and solicit which one of us. That's why we use a condition. That was the idea of itemization. So that's why we will say, well, I can't use this as directly, unfortunately, but I need to somehow come up with my own questions, which actually it takes. So that means I need to ask questions to identify what S is. So I need to place a question, and then based on this question, I will be able to access, and I know what S at the moment is. So how many questions I need to have at least here? 3. That means I need to have 3 branches of conditionals. Yeah. So that's the thing, 1, 2, and 3. So now, so far we have done 2 stages in the template. First, we put just S and checked what S stands for. Then we realized that it's an organization, itemization of different data structures. Actually, it could be an itemization structure and number, or something else. It's an itemization, a subset. Then based on how many items, different items we might have, we decided number of branches. But you need to realize that we keep, replicate S in every answer part of the branch, because I'm going to my purpose is to be able to access S. But what selector I'm going to use is the question. So you can't. You need to realize, and if you compare this template with the template for the other function, if it was a triangle, we would put just these kind of selectors, and we will make it ready to go. But at the moment, first of all, we need to identify which part, actually, which data structures. That's why we need to have questions. That's why we had these branches, and now we need to solicitize what each one of them is. So how can you check whether it's a triangle or not?
Structure name and
Yeah, now that's one of the built-in functions comes when you say define struct, and it was try data is the name of the name of the structure, and this will be the automatically generated function, and input is s. So now if this is true, I know that s stands for a triangle. And the same thing which should fit with the other things, we have rect data. We have, then I know that S is for rect data, and we do have circle data. That S is for the circle data. Okay. We need to have a question mark. This is just the name of the structure. Now it's a function name, which it's a predicate functions. Okay, my questions. So if you look at the thing we have done, the wooden template to generate code is first we put just the name of the input and checked our signature, our contract, to understand what it stands for. And looking at the data definition, we decided, this is itemization, so we came up with the number of branches, and then we formulated our questions, which checks which S stands for what. We know that stands for triangle in data, this stands for rectangle data, this stands for circle data. And most of you either doesn't have this part or ignore the rest. But it's not the case. Gökhan, what's the next stage to complete the template? So I don't feel that I'm ready to go think of how am I going to combine data I have, because the purpose of the template stage was make the data ready to go. Now I'm, at least for the timing, I know what this S stands for and this S stands for and the other S stands for, but still I'm not complete. Gökhan, did you have? Okay, Gizem?
We already know what is S.
Yes.
Rectangle, circle, and we can use the
Selectors.
Yes.
Yeah, of each for each. Now we will be able to finish up the thing. So we know that in this S stands for, obviously, for try data. Then I can use try data selectors, which is length, and this is going to get the length information, and we're going to have try data color, which is going to make the color information ready. So now I don't have to do anything else to be able to access my data. So I made sure that at this part of the code I have triangle information. So now for the circle rectangle information, we will do the same thing, but this case we have rectangle data, so we are going to use the selectors of rectangle. It was width, I guess. Which one we use first? It doesn't matter, but sometimes, okay. And then we will have adapt information for the rectangle data. So we have it here. And what else do we have? Yeah, so this is depth, yeah. And else we do have color of the S. So now we are done with this. Finally, we should be able to use the selectors of circle data. So we do have circle data for, what was the name of the circle data? Length or? So we use length, yeah. We could say that radius, which will be more sensible, because it's not length, but anyway, since you have to go and change all the things for S. For this S, I know is a circle, so I can use this selector, which is color for, again. Yeah, it's circle data, it's not circle. So if you look at so far, now we have completed the template. And actually that means you have so much code ready. And the final stage of implementation, you would think, how am I going to combine existing data to produce the output? So let's have a break and we'll keep doing the afterwards. So what we have done here was to complete a template. Oh, this is not, oh, this is the conference. You can attend, it's next September in Istanbul. We as a department, we are hosting this conference. Yeah, we need help. If you want to volunteer, please let me know. Okay. Okay. Anyway, now let's keep back. Go to the. We will later on. We will talk about that. So now we have done. What we have done is to complete a template of the function. I think someone else is going to hear me from here. Okay. So at this stage, we are going to complete the implementation. So in order to make sure that how we have organized our function based on the stages we have done so far, we keep our template intact, and now we are complete the implementation. So Gürkan, can you tell me how am I going to finish up this part? So in this part, we know that current shape is a triangle, and also we know that these data are ready to go. We have length of the triangle, because this is an equidistance triangle, and the color of the triangle. And now from this template, we want to move to the final implementation. As I have said, sometimes, like as we have done, we have completed it before this break, and we might have forgotten what was the purpose of the function and what exactly the function produces. So as a good stage to make interaction and interrelation with before stages, what I will do, I would refresh my mind looking at the purpose statement. And also I would refresh my mind looking at the examples. So I will check what kind of things I need to produce. Oh, for instance, for the triangle, we are looking, Gürkan is going to help us. We are looking at how are we going to complete the answer for the triangle. For this case, we know that we need to use triangle information, the built-in triangle function, and we need to extract the length, we need to extract the color, and we will keep it solid. So, and we know that this function renders images based on the input data. So now this is how we refresh our mind when we go further from the template to the implementation. This is necessary to go. Okay, so what should be the expression here then? I'm expecting Gürkan. Gürkan? What will be the expression to complete this part? So our signature tells that we need to produce an image. And then our example says if the current data is a triangle data, you should use the triangle information to combine pieces of data. So, Steven? So, what is the expression? Now, what are you going to do now? Yeah, we need to produce the result, but how are you going to produce the result? Isn't this so trivial and obvious? So, yes? Yeah, okay, we're going to produce an image, as you have said, but how are you going to produce an image? Now you have to finish up the implementation. Yağmur? I mean, I know you know, but you need to just open up your mind and just follow what we have done so far. Yes, Gürkan? So obviously, because example tells us what we should do. It says that use the triangle built-in function. So for this case, we say, yes, I'm going to use the triangle. And for the triangle function, it expects A length information. Where is the length information? It's over here. You don't have to do, how am I going to extract length information? It expects, as a third input, what does it expect? So we know that we are not going to play, it's not a variable for the case. We just say it's a solid thing. And then it expects a color information. This is the color information coming from the input data. So we are simply done, but it's just looking at the example and remembering what was the purpose of the function was. And that's why template is just a thing that helps you to complete the code. So it is part of the great part of the code. But it's not, you don't start designing your template, you start designing your template from the designing of data definition. So this is whole process, it's a process. Sometimes you go back and forth. And it's a whole process. That means you need to know what you are doing at what stage and how you are relating information you gathered at every stage. Otherwise, jumping into the how am I going to produce the code mood will not help us. Okay? So how about this case? F1? Right. It's going to be rectangle. So how many inputs does rectangle expect? We can make sure we can check our example because we checked this before. It expects width and depth. Yeah, and actually it expects 4, but we are going to keep this constant. Use the 3 variables, and we do have whatever we need to have. So that's the first parameter for the length parameter. This is the second parameter of the length. And now we will use this outline. Was it outline? Yeah, outline. And so this is the outline. Finally, we need to give the, maybe we need to do the color thing. Yeah, so this is not the case. Now we have everything. The color is there. So that means, we do forget before rectangle. Now it's a function implementation. So it's always good to do indentation to look to make things clearer when it gets messy. It will help us to follow, and so it's really easy. And always do the indentations. So now I realize that I do miss one other parenthesis. So this is the case for rectangle. And how about circle? Who's going to help us? Tucci? Yes, it's circle. And I said radius of the circle. It comes from here. And we decided to use solid or outline? Outline for the circle, okay. Oh, this is not how so this is the outline. And the color is ready. Yep. So now we have completed the whole function. This function not only works on a triangle, it works on different shapes, but not in all of them, but a subset we have decided. And if the current input is one of those items within the subset, we should be able to render a proper image for that. So now check if we have any errors to fix. So now it looks like it works. So you can try by hand, like let's say make a rectangle. Let's try to make a rectangle. It was rect. How was the name of the rectangle? It was rect data. Yeah, rect data. 2 numbers like 40 to 50, and so that was. And we need to have a color information, I guess. So again, an orange information, for instance. So it should produce. Yeah, it did produce. So you could use this function in any place you want to have. So how about, now we have completed the function, but it's not the part of the main function design, but once you have completed your design, there are different ways to improve your function implementation. Like you can improve your implementation if you want to looking at the efficiency and performance and also readability and so on. But in some cases you might need to throw out some error messages. Well, if you look at the schema we have following, we having a signature enforces our users just to apply inputs that we are expecting. We don't expect them to give do something. We don't expect someone running our function with something like that. So it's like, now what it tells us, it says, well, all question results were false. That means it's not one of the type we were expecting. So what? All questions results were false. Oh, this is a very philosophical statement. Anyway, so you can come up, I mean, of course, any programming environment or development environment comes up with some error handling messages. So let's simulate one simple thing. In our case, looking at our design, how can we throw out some error messages?
You are going to write an else case.
Yeah, an else case, obviously. So this is not the complete design. This is, you can do such kind of things once you have completed the design. But of course, in some other programming environments, practices, it becomes part of the design itself. It becomes part of the test suites and so on. But so you need to make sure that how you can deal with those unacceptable or exceptional cases and so on. So in our case, we will look at the func implementation, our own implementation, which is here. And as Kemal has suggested, we will use an else case. For any other cases, if it's not one of them, then we should be able to produce an error message. So for the answer, we will produce an error message. This is not correct because error message is a string. It's not an image. That's why we don't think this as a part of the whole design. This is a further improvement after we have completed design. Okay, just try to make sure when and where you deal with such kind of things. So we say like error, maybe, or maybe like this one, not this corner, it's error. It expects, what was the name of the data type? G shape, M shape. It expects M shape given, let's say, given this input, whatever the input is. So this should produce, I'm not sure, but let's see if it works that way. So let's try this one. So it highlights, it expects M shape given to a number. I wasn't expecting a number. Okay? Any questions so far? So now I want to move further, actually not from something really new, but it will help us to further on to be able to design more complicated data structure, like trees, like lists, like our different kind of recurs, and so on, like graphs. All those things are, usually it's your own data structure. And the idea behind this one is really simple. So what we have a single and simple tool, which is called define struct, which helps to organize our data. But using this thing, and it also has property that you can, within the component of the one compartment of the data structure, you can put another data structure of your own. That gives you infinite number of different possibilities in generating different data structures. So you can come up with really clever, smart data organization to accommodate lots of different information, large amount of information, in a very organized way where you can process them directly. So let's say, assume that we were, this function just done, so we can use it. Not assume that you were designing a simulation, like the current project. In the current project, you have a single circle, and it moves around, bounces from the ball and so on. But you could also have another options, like whether to put a circle there, a triangle there, whether to put any other shape. For instance, in this case, in your this data package, you don't only need to contain information about the shape, but also you need to contain information about the position, for instance. For this case, that means you need to go and organize your data. For that case, it's like your one of your object. So you will say my object is a data structure I'm organizing, and I give a name, object, let's say. Let's say there are all different ways to organize how you organize your data in the package. So you can have a flat package, a long number of components. Actually, there are many number of compartments that will allow you to access one of them in one step with one single selector. So you can say this is X position, Y position, color, radius, and blah, blah, and so on. Like there will be too many selectors at the same level. So in some cases, this is good to do. It depends on what function you do. I mean, this is part of the design decision. But in other cases, if you access a certain type of number, like inputs, like for the position, you always access X and Y at the same time. So instead, you can organize them into a position structure. So that's why, for instance, for the position, we can say, well, maybe I need to have, in this compartment, I'm going to put my position data into an X and Y compartment. That will be a POSAN. This is a built-in POSAN structure. So this is how you can keep, because you know, if you want to access the position of object, you need to access X and Y at the same time. That will be a reasonable thing to do, then combine them together. And for this part, for instance, you can say, I'm going to expect only those inputs I have designed. I mean, those data types I have designed. So what was the name of it? It's called M-shape. So that means it can be rect data, circle data, or tree data. So that means this one is another box, this one is another box, and this one is also another box but with 3 compartments. Okay? So that's this is how you can decide, well, I'm going to use those shapes. My current object can be one of them, but the positions are, so that means you can play with a key event where you can click one of the keys and automatically change the object without changing the position. So that will enable you to do such kind of things. So what I want to do today is to look at a function template for such kind of data organization. So how would you implement the template of this function? Because I have realized that somehow you are not so clear about when, up to what point I need to open up the template. Sometimes you might come up really messed up templates. So it's nice to be aware also how you organize your template, because organization of your template will help you to decide when to use a helper function. So that's a good hint about when to use a helper function. Most of the time can be determined by the organization of template. So that's why I'm going to give you a hint on that. So let's say we have a new data structure, like this data structure. We will organize it like object as our object. Since I'm going to use it, so let's say it's going to be define struct. So we are going to use our structure, and this one we will have a shape. It's always good to, and a position. So, but we need to make clear that what are they for. So we should say it's make object, M shape, or make POSAN. Number. Okay. So this is built-in data type. You can use it. So you say for the position, I'm going to use built-in position information. For the shape, I'm going to use M shape, which means it can be circle data, try data, or rect data. So this is how you make clear that this is our new organization. So you could use as your own world state, for instance. So now I want to ask you, how are you going to design a function, a generic function for, so it's going to be a generic function for object. We know that means it's going to consume an object. At the moment, we don't care about what are we going to produce. So what is the template for this function? So now I will start with the header, but I will let you to think about it. Okay. So this is the header. Can you follow this clearly? Yeah. So now let's complete the template altogether. What would you do? So now who wants to start with? Billy? You will give us the first step of the template. So there are multiple steps within the template where we do the design. So what would you do? I mean, I would indeed, even if you practice enough or you just follow, it's very mechanical. You will do about do the same thing, but you know what? If you know what you do, it's really mechanical. It's directly coming out. You don't have to come up with really advanced algorithm because there are enough hints and there are enough information how to come up with the template. AJ?
Maybe first we should give
Yeah.
examples.
Well, we can't give an example because we don't know what the function is going to produce. That's the point. Okay? So we need to, but we have enough information how to organize our structure of the template. Elif? You don't have to give all the, we have done it even twice in this lecture.
Maybe we need to write one term. Maybe
Okay.
make
But you think how to generate, but we don't know what to generate at the moment.
we can use draw function to generate everything.
But the thing is still we don't need to think what to generate. We need to of course I'm always asking the same question because I want you to know it. What is the motivation in a template? I mean, if you still hesitate, what you do immediately, that means still you need to go and read the material or see the lecture materials again. Because it should be crystal clear. It's not something that you need to hesitate. We haven't done anything, just trying to emphasize this over and over again. Kemal?
We are going to use objects.
So that means, so you'll say, well, I need to use my input. Oh, okay, that's a big step. Because that means I'm going to use my input. Then, because this is the input, what would you do?
We are going to call its components.
Yeah, then you will check what this input is. You will check the contract. It's an object. And so what's an object? It's a structure. And it has two components. So, what would you do? Yeah, that means you will select the components. So this is really simple. Yeah, you will get the data out of the component. So it's object dash shape will help you to extract the shape information. Object dash what is posan will help you to extract position information. Now, are we done?
No.
We are not done. So we have to check what we have here. What do we have here as a data type? M shape. So it's always good to write down what data type we have at the moment. It's M shape. How about this one? Oh, let's check. It's a position structure. It's a position structure. So that means, is it done? No, because I can't use M shape. I don't know what shape is at the moment is. And I can't use what pawn? It's a posan. I need to make sure that I can use it. So now that means you have to concentrate on this input. Still you have to concentrate on the input because you need to make data ready to go. But if it should remind you that you had a template for M shape, which is that one. This is the whole template for the M shape. And we are designing a template. That means we need to embed this template down in there, isn't it? So this is the decision moment, whether to embed the template here or say take a more flexible and modular approach. So it's a hint that, well, at this moment I'm going to use a function to deal with the shape. This function, the design of this function will use the template. It will open up the data and access the data. So this is really the decision point where you need to do. So in this case we will say, well, this is a not so easy input organization, but I have to, and it's a great hint that you need another function. So that in this case you say, I'm going to use a function f for m shape to deal with this. So what will be the output of this one? We don't know. It depends. It's going to be depends on what we want to produce. So now we have. That means you can go and design a template. Is it the same template now? You didn't mess up your design. You made it clear, and that has been a great point where you can decide when to use a helper function or not. But you have completed the purpose of the template because it helps you to open up whatever data is there, and so make the data ready to go. So that's why don't leave it as we had before. But still now we need to check this part. And this part is a position structure. Where was it? Yeah, it has two numbers. So you could have, but for this case you might. It's not. It sounds like it feels like you don't need to have another helper function. Maybe it's if you when you have a concrete function implementation, a purpose with and examples, you can decide, well, this is a complicated thing to do with, then you can come up with a helper function. But for the template case, in this case, you can say, well, this is a position structure, but it's not ready to use. I should open up it. So I know that's the post 10. It has an X component. So now it's going to be a number, and it's going to have a Y component. Now it's a number. So we know that this one is a number from that point on, and this one is a number as well. Now your template is complete for this thing. This is really clear. I mean, not difficult, but it's still important. Yes, Edith?
I'm going to ask how we can use this f for m shape function. Like we didn't define it before.
We didn't define before, yes.
So it will give error to like what is that?
Yeah, it will say it's undefined.
Yeah. So
Any suggestion or comments on that question? Elif said we didn't define f for m shape, or let's say func for f shape. So well, is it wrong, or what should we do? Yes, Junjai?
Actually, we're designing a template.
Yes.
And we use another template. It is func for m shape. Written in the above in our template. So we didn't write the same things again and again. So because it's a template, we can.
Yeah, we can use it. Yeah, I mean, yeah, exactly. So first of all, I mean, if to make it more obvious, you could say, well, if I'm going to need a function, and name of this function, I have decided, because I don't know at the moment what function is going to produce. This is a function for m shape, and I know that it's going to. Sorry, it's missing. I know. So it's going to have an m shape, and we don't know at the moment what it's going to produce. But this is a template we had before. I know this is not the whole answer what you were asking for. I mean, but that means. But the thing is, this is part of the design. Now we have the whole template ready. So the thing is, because this is also a matter of a top-down design approach. Well, don't try to have all functions ready to go. So you can always make wishful thinking. This is a way of top-down design. So well, in this case, I need a function called func for m shape. And then once you have completed the body of this function, then you can go and implement it. It is not wrong. This is why, because it's a design. You don't have to go very linear. It shouldn't be very sequential. You can always go back and forth in the design, and that's the spirit of a good design. And this is particularly like a top-down design approach. At the moment, you say, I need a function which consumes m shape and produces whatever I need for it. Then that means your brain is okay with that. Like now you can concentrate on the other parts of the function. Because once you come to implementing this function, it will be easier. Because the data is much simpler, and it's also you can use existing templates as we have done here, and then you will do things accordingly. So I know what you are confused, because I want you to be confused and make sure that for the template, of course, this is not very universal, but for the things we have done so far, you don't need to know what it produces. You should be able to come up with a template, even though you don't know what the function is going to do. That's the idea. That's the idea behind using a template, because it's based on data organization. Okay? So actually I am done with the things, but I want to give it a small push so you can do the reading of the next week, so we can concentrate on recursive functions. So how about, instead of, no, this is not a good one. So if you had, let's do something. Oh, we can say okay, now I'm going to just, we don't have to ask me, well, for what reason? I'm going to have an object again. In this object, I'm going to put a number in this compartment. And I say, okay, I want to put another object here. Okay? So that means this object has a number and probably something else. Okay? It's not, so does it make sense? It's a strange thing. Go and read the next week material. So what I want to do is, let's write a template for this data organization. So that means, so let's do the template for this thing. So we have this object as the input, like it's a function for this object thing. We don't know, it doesn't matter at the moment what it produces again. Okay? So I want you to design the template for this function. For opt. Yep. Again, let's say we have the object. Okay. So what are you going to do? The template. Yunus? So this is the template we want to. We have two. Well, I didn't define the structure. Sorry. So that's why you were hesitating, I guess. There's a defined struct. Did we have it? Yeah. So we can change an object and a value and let's say inner or left component. We have a value which is a number. And a left component. So that means it's make object, or it starts with capital letter at the moment. It's a make object, a number, and again that's an object for short, because it's got, again, make object and so on. I would keep writing. Is a number make object? Is a number make object? Is number make object? So this is something interesting you need to look at. So that's why, to keep it short, I have done so. But let's look at how we can reflect this to our design. So you say you want to write the selectors for this one. As object, a dash value will help you to extract the it will help you to extract the number. Okay, so and also you need to have the selectors object dash left was the name. What is it going to extract? Again, an object. So this is the thing we have ended up. So as we have seen from an earlier example, this is fine. We want to open up the data. How about that one? It's again object. So that means that actually you need to have a template, the same template, embedded here. So, but there was another thing we have seen. That was also a point where you can decide, well, this is the point where I can write a helper function. So what would you say? You would say a function which consumes an object. And so that means you would say write down a function like this one. Function for object. But now let's examine this. Doesn't it sound strange? How? I mean, of course, I'm not just like using my natural language. So I came up with the input, the same type of input, which needs to be designed. I need to be used for the design of a template. So the template should be the template of the same function. I mean, this is simple. We just followed the same principle of how to apply a template for the data, how to reflect data organization to our template. And we will come up with something like that. Okay, does it sound strange, or I mean, isn't it reasonable? Is it logical in first place? We have been just straight logic of our mechanism for the extracting template. But if you implement this one, that means you are applying a function within the function. What does this sound like? Does it imply anything? So it's like you call a function within the function. So it's a recursion.
But it's another the same names different.
Oh, is it? Oh, sorry. So now, that's why you were looking weird. Okay, now it's fine. Yes. Thanks. Live debugging. So this is the subject of next week. I want you to think about that and look at the reading. This is exactly simple transition to recursive function design. We just followed the principle of designing a template, and it depends on how you design your data. So it all starts with data. Okay? See you next week.